So let's first tackle frictionless problems. The problem goes, the block shown as a mass m equals 7 kilograms and lies on a fixed, smooth, frictionless plane. Tells it an angle of theta equals 22 degrees from horizontal. Determine the acceleration.
Okay, so basically to solve this problem, you use the properties of vectors. So because it's frictionless, there's only a force in the x direction and there's not one in the y. And so for the force, it equals mg sine theta. And so we are given m, and we know that g is the acceleration due to gravity, and we're given theta. So using that information, we know that F equals 7 kilograms times 9.8 meters per second squared times the sine of 22 degrees. And so what we did is we solved for that, and we got one answer. And we know that that answer is equal to ma. And because ma is equal to 7 times the acceleration, we can cross out the 7s. And so we divided this answer we got by 7, and we got to the acceleration of 3.671 meters per second squared.
Is an example of inclined planes with kinetic friction. So the example goes, the skier has begun descending the 30-degree slope, which is this figure. If the coefficient of kinetic friction is 0.1, what is her acceleration? So in order to solve this problem, we need to think about the coordinate system and the vector components. So I drew the diagram here where the force of gravity is pushing down, and so to think about the vector components, you have to think about the force of gravity in the x direction and in the y direction, and then the normal force. Then the force of friction is perpendicular to the normal force, and you are given the 30 degrees. So for the force of gravity in the x direction, the equation will be mg sine theta, and the force of gravity in the y direction will be negative mg cosine theta. So with Newton's second law, you want to find the sum of forces in the x direction, which equals max. To solve for the summation, you want to plug in the f of g of x, which is mg sine theta, minus the force of friction that's pushing it back. So the equation would be mu k f normal force equals max. And for the y direction, it's similar, except you are using the normal force. So the summation of f of y equals f of n minus mg cosine theta, which equals may, which equals 0. So you know that f of n equals mg cosine theta. So then you substitute from the previous equation, and you get mg sine theta minus mu k times the quantity of mg cosine theta equals max. And then when you start plugging in the numbers from the diagram, you get a of x equals g sine 30 degrees minus mu k g cosine theta. And then you solve for a of x, which equals 0.41 g, and you know that g equals 9.8. So a equals 0.41 times 9.8, which equals 4.0 meters per second squared, and that will be the acceleration.